So let's go, please.
Okay. Yeah, so first of all, sorry that I'm without the camera, but it is really uncomfortable for me right now to turn it on, and it is quite dark here, so you won't probably see me. Yeah, so today is the topic that I want to discuss is smart contracts on Ethereum. So we'll talk about what they are, how to write them, and what are the basic concepts, and we'll also go through some examples, and I will briefly go through Ethereum virtual machine features so you could understand how smart contracts work. So what is a smart contract? In Ethereum terms, smart contracts are immutable decentralized programs that run deterministically in the context of Ethereum virtual machine. They are actually neither smart nor legal contracts, but the term has stuck. I believe the first concept of smart contracts appeared in the 90s as some decentralized programs that somehow work magically work. But in the context of Ethereum, smart contracts, first of all, are immutable. What it means is that once the contract is deployed, it can be changed. More technically, when the bytecode of the smart contract is placed in the Ethereum virtual machine, you can't change this actual bytecode. So smart contract behavior may change because users will interact with it and it has to react to the transactions, but the actual program that smart contract represents is immutable. Secondly, smart contracts are decentralized because Ethereum is a decentralized network. Then everything that is on top of Ethereum will be also decentralized. Programs, because you can program smart contracts, and because Ethereum virtual machine is Turing complete, it means that you can do pretty much whatever you want. You can write anything on Ethereum, but virtual machine has several limitations that are there. So Ethereum is deterministic and pretty simple for the nodes to run because it has to be decentralized, and there are resources wasted to keep the decentralization up. But yeah, technically, Ethereum virtual machine is Turing complete, and languages that compile to the bytecode are also Turing complete. And smart contracts in Ethereum are deterministic. This means that there is no on-chain random at all, and every function, every code that virtual machine uses to execute has its own deterministic outcome. So there are no so-called side effects. Yeah. Smart contracts are usually written in a high-level language like Solidity or Viper, and then compiled to bytecode. Yes, EVM doesn't understand high-level languages, but it does understand low-level bytecode. It is pretty much like code. For example, processor architecture also has its own code that it interprets and runs. Java virtual machine also has its own bytecode, and it's somehow structured and defined. Ethereum virtual machine has its own type of bytecode, which is also defined, structured, and pretty easy to navigate through, actually. It is much simpler than, for example, Java bytecode. Smart contracts are used to bring real-world concepts and value to Ethereum. Yeah, so this statement means that with smart contracts, you can code whatever you want. If you have an idea, you can implement it with the smart contracts. And a lot of real-world concepts like finance was brought to Ethereum, but from like a different perspective, because yeah, you have to adapt the programs for Ethereum. So traditional finance became decentralized finance, for example. Okay, so let's talk about the life cycle the life cycle of a smart contract on Ethereum. So the number one, smart contract is designed, implemented, and compiled by bytecode. Nothing new here, as smart contracts are just regular applications. First of all, you have to think a lot about the idea of the application. Then you have to think about the architecture of the application, and etc. Smart contracts are implemented usually in a high-level language, for example, Solidity, and then this high-level language is compiled to the bytecode. Number two, smart contracts are extensively tested and audited. In Ethereum, like in the world of Ethereum, it is super important to write tests for the smart contract, to do a lot of review, and to have an external audit of the application you are implementing. It is important because smart contracts are immutable, meaning if there is a bug in your application, then it is really hard to fix it, because either it has to be like possible to, for example, somehow fix it, and smart contracts have to allow this behavior, or the application itself has to be written in a certain way so those bugs are fixable. But usually when there is a bug, then the funds that smart contracts operate with are vulnerable, and hackers can, for example, drain those funds. External audit is a really, really important thing, because when another pairwise that are out of the context, out of the implementation, looking at the code, they can like pinpoint to the problems that code has, and usually those guys who audit the code have like a lot of experience and knowledge how to like mitigate the bugs and the problems. So in the end, probably every protocol, like every major protocol, is tested a lot, audited a lot, and it is pretty safe to use. Then point number three, smart contract is deployed via a special transaction and its address is determined. Yeah, so from the previous lecture, I hope you remember that there are three types of transactions, like three main types of transactions in Ethereum: the regular ones, the contract deployment ones, and the transactions that interact with the contract. So to place the smart contract on chain, you have to assemble a special transaction that has the to field as address 0 and the data field as the smart contracts bytecode. Then this transaction is sent to the network, and once it is added to the block and the block is added to the chain, your contract will be given an address, and after that, you're allowed to interact with it somehow. Number 4, users atomically interact with smart contracts either directly or through decentralized applications. The contract may in turn interact with other contracts. Yeah, so once the contract is deployed, you can call the functions, the functionality of the contract, either directly. What I mean here is you can use the node, the Ethereum node, and send requests to that node. And the node will interpret those requests as you send them, and interact with your smart contract. Or there are special libraries that are built, for example, in JavaScript or in Python that may be used to that are built on top of those low-level interactions with a node, so it is more convenient to interact with smart contracts. And decentralized applications do exactly that. They use those special libraries that send requests to the desired node and do everything under the hood. And smart contract may interact with other smart contracts. What I mean here is that Ethereum as a blockchain is isolated from the outside world, so you can't query anything from Ethereum, but you can do whatever you want inside the Ethereum. Every smart contract may call another smart contract, or may even call itself. And those interactions are completely atomic, meaning that if any of those smart contracts fails to execute or reverts, then the whole transaction reverts. And the state that is applied or changed will be reverted to the original state before this transaction. And point number 5, smart contracts may be destructed if they allow so, but it is a deprecated feature. There is a special built-in function into the Ethereum virtual machine. It is called self-destruct, and smart contracts may implement this function if they want, and under certain conditions, the user may call those functions, and the code that is placed beneath the smart contract will be destructed. Ethereum that the smart contract holds will be sent where you want it to, but right now it is already a deprecated feature that was deprecated 2 weeks ago in Solidity 0.8.19. So this logic is discouraged right now. Okay, so let's talk about smart contract execution environment, the execution environment that Ethereum virtual machine operates with, and what smart contracts operate with, and what is smart contracts in whole. So first of all, Ethereum virtual machine is a stack machine. Oops. typo here. Meaning that everything that happens with smart contracts happen in stack. That every variable that you operate with, every function argument is placed on stack. And for example, if you want to add those values, the topmost and the second topmost elements from the stack will be popped. And the add operation used, and then the result will be, the addition will be placed onto the stack, so the result will be the topmost elements. And those low-level operations are called opcodes, but without E, it is a typo. And those opcodes operate with stack itself. There are a lot of peculiarities about stack, that it is, so each transaction may have the maximum depth of stack to 1024, 1024 elements. If you go above that limit, the transaction will revert. And the second peculiarity is there are certain operations that can take elements from the stack or duplicate elements that are in the stack. And you can't access the element that is lower than the 16th element. So each function can only access up to 16 elements at any point of execution. It is quite a roadblock, because when you want to implement some really complex logic, you will like bump into the stack to deep error, and it is really confusing. So this logic has to be refactored, and etc., etc. And then there is memory. Memory, it is a special location where smart contracts store dynamic variables. For example, if you wanted to allocate a dynamic array in the Ethereum virtual machine, the elements of this dynamic array would be placed in the memory. Memory is not infinite in EVM. However, there are a lot of like memory locations that you can access. Actually, 2 to the power of 156 minus 1. It is way above the 64 bits. It is 256 bits of memory that you can access, but the higher the bit is, the more gas you will have to pay to allocate memory there. So if there is a complex function that, for example, allocates 100 array elements, those 100 elements would cost X gas. But if you wanted to allocate 1000 elements, which is 10 times more, then the price would be squared. So the price would be 100 times more. So memory is allocated quadratically. The cost of memory allocation is quadratic. Then there is a special data location called call data. It is the place where EVM takes arguments from. So when you want to call a smart contract, you will place like encoded function call into the data field in the transaction. And this data field is actually a call data that Ethereum virtual machine will take, decode, and understand how to use those bytes that you provided. This data location, once available in the smart contract context, it is read-only and can only be written when the new function call is made. Then there is a return data. It is similar to call data, but call data is used when you are calling something, and return data is used when you are returning something. So when you call a smart contract, it may execute something, count something, and return the result. So this result will be placed into the return data location, and then other smart contracts or your front end or application will get those bytes, and you will be able to decode them and understand what is actually returned. Then there is a very important data location called storage. Storage is the smart contract state that cannot be changed without a transaction. So storage is where the like variables are stored between the transactions. It is what determines the state of the smart contract. Storage is also not infinite. It is limited to 2 to the 256 minus 1 storage slots, and each of them is accessible. You can place whatever you want there, and if your program is designed to understand what is written there, then it can read it and everything will be fine. So this storage cannot be changed without a transaction. We remember that in Ethereum, only externally owned accounts can initiate a transaction, so smart contracts cannot. And smart contracts cannot react to some events. Only externally owned accounts can. And if you're executing a transaction, then this storage may be changed, may be altered, may be modified. Else, you can only read from the storage. Then there is a data location called call stack. It is actually used to remember in which order the smart contracts are called to appropriately return to the caller. Usually, this data location is emitted if you're reading some articles, for example, or some Solidity, I don't know, tutorials, but it is important to understand that there is one, and using this call stack, Ethereum virtual machine actually understands where to return the execution to. And the last one, the bytecode. It is the bytecode that the language compiler compiled your, for example, Solidity file to. it is the logic of the smart contract. It is the actual program that Ethereum virtual machine runs and interprets. And as I already mentioned, it is immutable. So it cannot be changed. Okay. So let's talk about Solidity briefly, because Solidity is the famous and most popular smart contracts language probably in the world, but surely in Ethereum. So Solidity is a contract-oriented programming language created by Kevin Wood. The main product of the Solidity language is SolC or Solc, which converts programs to AVM bytecode. And the latest version of Solidity is 0.8.19. So we don't even have a release right now. Yeah, so that's pretty much it about Solidity here. And here is a smart contract example written in Solidity. Let's briefly discuss what it does and how to read the example here. So on the left, we have a high-level Solidity smart contract, and on the right, we have a compiled smart contract into the EVM bytecode. So what do we have here? We have the contract name, contract example. Then there is an event defined. The event, if you remember from the previous lecture, we had a data structure called a logs bloom. It is like a special feature of EVM that allows you to place, like to track some action and to have it easily discoverable. So here we define an event called received Ether, and the argument of this event is the amount of Ether that is received. Then we have an address called owner. This is the storage variable. So this variable can only be changed inside the transaction, but it can be read without the transaction. So there are actually two ways to interact with smart contracts on Ethereum. The first one is through the transaction when you want to modify something, and the second one is through the call. The call doesn't require a transaction. Anyone can call like whatever they want. There are no signatures. There is nothing there. It is just a special request that the node interprets and calls special functions that are meant to be called without transactions. So in this contract, there is one such function. It is the owner function, even though it is a variable, but because we have a public modifier, Solidity compiler auto-generates getter for this variable. So meaning that you will be able to call and get the owner of this contract without a transaction. So then we have a constructor. Constructor is executed once when the smart contract is deployed. here we have the message sender. It is the deployer of the smart contract. And on the left, we have owner. So the owner of the smart contract becomes the deployer. Then we have a receive function, special solidity function that allows smart contracts to receive Ethereum. It has special definition, and it emits event that smart contract received Ether. And as a parameter, the message value is passed. It is the amount of Ethereum that is sent with the call or with the transaction. And then we have a function that can be called only by the owner of the contract. We have a statement here that require that the message sender, the one who calls the contract, who it is not the original transaction sender, but it is the one who actually called this function. And we require this caller to be an owner of the contract. And if this statement is false, the execution is reverted, and everything that happened inside this transaction will be reverted. Then we are transfer. So if the statement is true, if the caller is the owner, we have to send Ethereum that this contract owns right now to the owner. So because we have already verified that message sender is owner, we can use the message sender here. Then message sender, it is actually an address. So this address, the type of message sender is address. And this type has function call, and we pass as value the balance of the contract. And this is just an empty byte. So message sender will receive Ethereum, and so whole balance will be transferred to the message sender. Because this call is a low-level operation, it actually does not revert on failure. It returns two parameters. The first one is the Boolean flag that execution is successful or not. And the second parameter, which is emitted here, it is the return data. Right now, we don't care about the return data, so it is emitted. And we have to check that call is successful, so we require it to be true. Else, the execution will be reverted and everything will be reset. So I won't talk about the bytecode here. It is here for you to understand how EVM sees the smart contracts. Draw a lot of moments about the bytecode that can be covered, but in a completely different lecture, because the bytecodes consist of like several sections, and it has like its own structure. But yeah, I will not cover it here. Okay. Then there is a question. How do decentralized applications interact with smart contracts? So we have this smart contract that is compiled into the bytecode, and this mess is placed on chain. But how do you actually know that the smart contract has the functions and know which parameters to pass into those functions? So in order to help with that, compilers together with the bytecode, they produce an application binary interface, or ABI in short. ABI of the contract from the previous slide is presented here, and let's quickly go through it. So here we have the first curly braces. We have a constructor which is non-payable, meaning that you cannot deploy this smart contract and set the value to non-zero. The deployment will fail in that case. So this smart contract can't receive Ethereum upon creation. And constructor has no arguments to operate with. Second curly braces are information about an event. We have an event name, type event. We have an event name received either it is not anonymous, it has one input field, array consisting of one element, which is not indexed, has type of uint 256 with name amount, and type uint 256. So there are two types, but right now they match, but there are certain types that like EVM and Solidity differ. So for example, Boolean, internal type will be Boolean, but the actual type will be uint8. The third curly braces is the owner function. We have a type function here, which is state mutability view, meaning that it cannot change the state of smart contract. The name of the function is owner. It accepts no parameters and returns one parameter with the type address, and this parameter is unnamed. The fourth curly braces is our function withdraw ether with state mutability non-payable, meaning that it can change the state, but it can't accept Ethereum. In order for it to accept Ethereum, the function has to be explicitly specified as payable. It accepts nothing and outputs nothing. And our receive function, it has a special type receive and state mutability payable, which means that it can receive Ethereum. So this JSON file is fed to an application. It is stored there, for example, on the front end. And with its help, we know how to encode the data that we are going to pass as the data field. And this information helps us encode this data. And the encoding we're going to use is called ABI encoding. So pretty simple. ABI standard, ABI encoding. Yeah, I won't go into the ABI encoding itself here. So probably in another course. Yeah. So then what are ERC20 and NFTs? So first of all, yes, these are the most used token types that are present on Ethereum. The ERC20 is the regular token, like cash or Ether itself. So it is fungible, meaning that one unit of token is interexchangeable with another unit of token. And NFTs, these are usually collectibles or standard to represent something unique, non-fungible. So individual unit is not exactly the same as another individual unit. And the specification of those standards are described in the AP20 and the AP71. So if you're curious, you can read through them. But what I want to point out here, that those are just ordinary smart contracts that follow the specification. So for example, when you see in your wallet USDC, that means that there is a smart contract that follows the ERC20 specification. It has special functions. Those functions have they like execute in a standardized way, so we know how to call those functions and what to expect from those functions. So your wallet actually knows the address of the USDC smart contract, and it goes on the smart contract and calls the function that returns your balance and displays the balance in the wallet. And what happens when you transfer the ERC20 token? Your wallet knows how to operate with this token, so it assembles the transactions in a way that two parameter will be the USDC address, the USDC contract address, and the data parameter will be the encoded transfer. ERC20 has a lot of functions, but one of them is the function of transfer. So your wallet encodes this transfer according to the ABI rules and sends this transaction. So the USDC smart contract executes it and updates the balances of your account and the accounts of the friends you're sending the money to. Here are some examples of ERC20 tokens. So it is the USDT, USDC, DAI, etc. And examples of NFTs or Bored Ape Yacht Club, collection, CryptoKitties, and etc. One thing that I want to point out with the NFTs is that the first non-fungible token to be are CryptoPunks, but CryptoPunks do not follow the 71 specification standard. They are different, which is a lot of pain when you want to interact with them. But they are non-fungible in their core concept. And pretty much one of the most important questions here is why smart contracts are so attractive for hackers. So pretty much every week and every month, we hear that some protocol is hacked, like millions of dollars wasted, stolen, and blah, blah, blah. So why is it so popular? So first of all, smart contracts work with value. So every smart contract will pretty much interact with ERC20 tokens or NFTs. Both of those standards represent some value, and nobody wants this value to be stolen. Then every Ethereum virtual machine peculiarity is really hard to embrace. It is true because there are a lot of pitfalls, there are a lot of caveats to understand, and it comes with just interesting industry knowledge and everyday like work with smart contracts, with the audits, like reading code, writing code, looking how others write code, reading postmortems of hacks, and only like with experience comes the understanding how EVM actually works. And usually when developers write smart contracts, they are under pressure. There are deadlines, and it is really easy to do something wrong or to forget about something. So yeah, there are a lot of like attack vectors on smart contracts that are pretty easy to fall into, and it's really hard to have them all in mind when you're trying to implement some business logic. Then innovation is a trial and error. So here I want to say that Ethereum is still like an innovation, that it is a never like stopping, never stopping growing environment. And if you want to build something new, you will probably like you will go through like a lot of errors, and when there are new protocols released, like there is high chance that if they are doing something new, they're doing it wrong. And the simplest thing, that human errors might cause a lot of problems, especially on Ethereum, because bytecode is immutable. Everything is pretty hard to embrace, and simple errors cost millions of dollars. And Ethereum Classic is just a great example. Ethereum Classic, if you don't know, was born because I believe the early stage DAO was hacked, and they just forked Ethereum and used like a block that was before this hack. But the true Ethereum fans said like, no, we will host our own nodes with true history. Yeah, so Ethereum Classic was born. Okay, so this is it. If you have any questions, please go ahead. How often use non-solidity language for smart contracts like Rust? What is better? Actually, Solidity, yes, it is the most popular language. It is used probably 95% of times, and the other 5%, or maybe 4.9, is Viper, and the other 0.1% is the Bayer assembly called U. You can actually write smart contracts. They're really low level in assembly that will be like directly compiled into the bytecode, but you are the one responsible for everything. Right now, there is no Rust to EVM compiler because Rust, it is a general purpose language that is really hard to compile into the limited bytecode. So it is much easier to develop language from scratch, like Solidity or Viper, that are intended to be used on Ethereum. And what is safe? The safest is the one that is used the most. But yeah, so it's a rule of thumb that safest is the one that used the most. But in terms of compiler, like bugs and everything, it is like Solidity is the most robust one. But those bugs are actually nothing with the human errors. So I personally use top idea for a developer now. I personally use VS Code with plugins, but a lot of folks that I know use IntelliJ IDEA.
Okay.
Maybe, can you hear me?
Yeah.
Yes, you have.
Oh, great. Maybe I could ask one more question. Is there a way to emulate the blockchain on your PC? So basically, do something like Remix does on in internet, but on your PC. So to use VS Code as a IDEA and some software to emulate the blockchain. So you could download some smart contracts and to see how it works, to create some transactions and so on and so
on. Yes. So the most popular blockchain that is like proof of authority, super lightweight, called Ganache. But like raw Ganache is like you can use it, you can download it, it's completely fine. It is amazing, but I personally prefer Hardhat, which is the like huge framework for building smart contracts, where the Solidity is integrated, where this blockchain is integrated, where the tests are integrated, and everything works in like as a one simple but really powerful tool to develop smart contracts. Right now, there is a trend to hop from hardhat to Foundry. Hardhat, like because hardhat is written in TypeScript, so you will be forced to using JavaScript and writing tests in JavaScript, etc., etc. So true, like backend developers use a different approach called Foundry. Foundry is written in Rust, and you'll be writing tests in Solidity directly because they have like slightly changed the Ethereum virtual machine to enable like features like signatures inside the Solidity. So a lot of fun.
Thank you. Thank you very much.
Okay, thank you. Thank you, Artem. This was a small part of our big course. Today, I will add more quiz and materials. See you next time. And let's talk about DeFi. We have some questions, Artem. Where is I can read about patterns and best practice?
Yeah. About patterns and best practices for contracts. So there is an amazing book about Ethereum. It's not about like smart contracts that I can definitely recommend. It is called Mastering Ethereum. I like personally use it as some reference when I like forget something or want to recollect. About smart contracts and patterns, you should probably check what is already developed, like the Uniswap, Aave, Curve, YORM protocols, and try to understand how they work and how they are implemented, because they are like the top-notch protocols that use advanced math and algorithms and economics to work. So they are like the best. And also you should probably read the Solidity documentation. It is really extensive. It has a lot of examples, how to like do something, how to not to do something, and do a lot of practice. So try to write like an ERC20 token, understand how it works. Look at the Open Zeppelin, for example, how they implemented the standard, what they are using, and yeah, go from that. So because Solidity is quite in this early stage, there is like no books about patterns, there is no standard libraries built into the language that you can use, but there are plans to add one. So you just have to dive into the industry itself and try to understand how everything works. Yeah, join some communities, developer communities.
Okay. Thank you. So maybe we can stop and see you soon. If you have some question, please write it's in classroom. We all time ready to get answer. Okay. Have a nice day. Have a nice night, and goodbye.
Bye.
Goodbye.